So at the end of this video, you will understand why this circuit is called the non-inverting amplifier circuit. So we start out with our constraints, that is Vp equals Vn, and Ip equals In, which is equals to 0. Now Vn is the voltage at this node. Vp would be the voltage at this node. In is the current flowing here, In, and Ip is the current here. So let's try to write an equation connecting V0 and Vn. And what may not be apparent at first is the fact that the combination of this resistor and these two resistors and these grounds make a voltage divider because no current flows in this direction. So we can write it as the voltage across Vn is the voltage across the RS resistor, and that would be Vn equals RS over RS plus RF multiplied by V0. Okay, because this is a voltage divider. When you connect this, you get a voltage divider. Then we can come here and we can say that since if we call the current here IG, that means the IG equals IP, which is equals to 0. And what is the value of IG? The value of IG is going to be Vp minus Vg over Rg. So we have Vg minus Vp over Rg equals 0. If that is the case, that means that Vg minus Vp equals 0. Then we recall that Vp is equals to Vn. Then we can just substitute Vp here, and we would have that Vg minus Rs over Rs plus Rf V0 equals 0. And what does that tell us? That tells us that V0 is equals to Rs plus Rf over Rs, over Rf. That should be over Rs, over Rs multiplied by Vg. So let me write that Rs plus Rf over Rs equals multiplied by Vg. And the point to this is that there is no negative sign here, so the input voltage is not inverted. That is why we call it a non-inverting amplifier.